Let us now discuss measurement of temperature. Remember, this chapter 1 is on measurement. So what is the learning goal on this section? The learning goal on this section or in this section is to be aware of the 3 temperature scales that are used. Let's say you're going to be in nursing school. You should know which thermometer you're looking for or you're working with. You might be using a Fahrenheit thermometer, and then it's going to read high numbers and you think that someone is dying, yet you are used to just using a Celsius one, which will give you less values. Or you mistakenly use a Celsius thermometer, yet you're used to the Fahrenheit, and you see the numbers are so low, you think, oh, this guy is freezing. So it's very important to know and be aware of temperature reported in Fahrenheit, denoted by not F, degrees Celsius, denoted by not C, or Kelvin absolute scale. Okay, so that is the learning goal. Now there are 3 formulas we can, 3 or 4 formulas we can use to interconvert these units. But before that, what is temperature? Temperature is a measure of how hot or cold an object is. An object can include humans, can include a substance like water, alcohol. It can be your body temperature. It can be you cooking or you baking your turkey. It's Thanksgiving. So temperature is a measure of how hot or cold an object is. Now, I just mentioned that we need to be aware on how we can interconvert these scales of temperature: Fahrenheit to Celsius, Celsius to Fahrenheit, Celsius to Kelvin. And there are these formulas here that we can use to just do that. I'm going to show you some examples, calculation examples. Part A, we want to convert degrees Celsius to degree Fahrenheit. You use that formula, whereby you are taking 9/5 multiplied by the given degree Celsius and add 32 as a constant. That will end up giving you an answer in Fahrenheit. Part B, you want to convert your degree Fahrenheit temperature to temperature in degrees Celsius. So in this case, it's going to be 5/9 multiplied by the difference between the Fahrenheit temperature value that's given in the problem minus 32. Okay, that will end up giving you the temperature value in degrees Celsius. Part C, you want to convert degrees Celsius temperature to the Kelvin absolute scale. How do you do that? You take your given degrees Celsius temperature reading or value and add 273.15. The answer that you get is going to be in Kelvin. The temperature will be in Kelvin. And then part D, here, if you use this formula, if you want to convert the temperature in Kelvin to temperature in degrees Celsius. Okay, to get the answer in degrees Celsius, you take your given Kelvin temperature value and subtract 273.15. Yes, I insist 273.15, not just 273. Most books will do 273. No, no, no. Always use 273.15 to get the accurate, precise readings. The next slide is showing you different thermometers, which I was talking about, that you really want to be sure what thermometer you're using. And the thermometer will always have their scales from the manufacturer. They usually type it on the glass. Okay, so the slide is showing you 3 different thermometers. The first one, it reads in Fahrenheit. The second one, the middle one, is in degrees Celsius. The third one is in Kelvin. So let's call this A, let's call this B, let's call this C. They all are used to measure how hot or cold an object is, a substance is, and that is what we call temperature. Now, if you look at 100 degrees right here, in the Fahrenheit thermometer, it will read 212. In the Kelvin, it's gonna read 373 Kelvin. Of course, the difference between here is 273, but I said it should be 273.15. Okay, so we have to be very careful. If you are reading in degrees Celsius, you read a 0, Kelvin is gonna be 273, which is why we are saying if you want to convert your degrees Celsius to Kelvin, you add 273. So to Kelvin scale, you take your degrees and add 273. For us, we say 273.15. There's a different formula converting from degrees to Fahrenheit, which is A. We add 32 to the multiplication of 9/5 and degrees Celsius. So I think we are ready to do some examples of this. Example number 1, question to you. Convert 110 degrees Celsius to Kelvin scale. Okay, so which formula do we use? Do we use A, B, C, or D? Since you're going from degrees Celsius, so the given is a scale degrees Celsius, and you're going from degrees Celsius to Kelvin, the formula that I need to use here is C, this one. And the way we do that, we'll say temperature in Kelvin is going to be equal to our temperature in degrees Celsius, and we add 273.15. Don't forget. So it's going to be 110 plus 273.15. Okay, and that's going to be, so simple math, you can do it over in your head, but for me, I don't take chances. So it's 383.15 Kelvin. That is the temperature equivalent of 110 degrees in Kelvin scale. Okay, so now let me give you another problem. Okay, so here remember we used C, formula C. Next, I would like us to convert 110 degrees Celsius to Fahrenheit. So now which formula we are going to use? We are going to use, so we are going from degrees to Fahrenheit, we are going to use A. We are going to use A. And to use formula A, we will have to take 9/5 of our given degrees Celsius, multiply there. When you do parentheses, it's multiplication. And then we're going to add 32. So it's going to be 9 all over 5. And we're going to multiply 110 by it. And you're going to add 32, which is just part of the formula. So let's come here in our calculator. 9 divided by 5 is what? What about we multiply that by 110 is what? Okay. What about we add 32 to that is what? So it's going to give me 230 Fahrenheit. So what this is telling me is 110 degrees Celsius is really 230 Fahrenheit. That's the conclusion. Question number 3. I would like you to convert 550 Fahrenheit to degrees Celsius. So to do so, what I will do, I will use formula B. We'll use B because that's the one that's moving from Fahrenheit to degrees Celsius. So use B. Let's just say use B. And in that case, the formula is degrees Celsius equals to 5/9 of the difference between degrees Fahrenheit minus 32. All that is left for me to do, my friends, is just to plug in the numbers. So I was given 550 Fahrenheit minus 32. You can use PEDMAS. Is it PEDMAS? Please excuse PEMDAS. Please excuse my dear Aunt Sally. So we do have parentheses. That's where we should start. That's the P. So we can say 550 minus 32 is 518. So we'll need to do 5/9 of 518. So let me just say 5 divided by 9. Okay, and then did we say 518? Why did I put 519? 518. And then multiply that by 518. So the answer I'm getting is 287.7 recurring. I think I'll keep it like that. The question will tell you how many sig figs to report the answer to. This time I would like you to convert 947 Kelvin to degrees Celsius. So the one formula I'm going to use is going to be the last one, the D. So use formula D as labeled, okay? So it reads, to get degrees Celsius from Kelvin, I'll take my Kelvin value and subtract 273.15. And in that case, I will be taking my 947 Kelvin here and subtract 273.15. Clear my calculator. 947 minus 273.15. Do this. The answer is 673.85 degrees Celsius. So far so good. I give you another example. Okay, so now this time around, the last example I'm giving you here, I would like you to convert 300 Fahrenheit to Kelvin scale. Now you'll have to use a combination of the formula. The strategy, the plan here, we'll have to take the Fahrenheit to degrees Celsius and then we can take it to Kelvin. Okay, and I'm going to divide this to 2 so that I can make it easier for me. I'm out of page. So to convert Fahrenheit to degrees Celsius, I'm going to use formula B. So if I'm using formula B as labeled, my degrees Celsius will be 5/9 300, that's the TF, minus 32. If I do the math, okay, 5 divided by 9, and then we are going to multiply this by 300 minus 32. Okay, so it's going to give me 148.89.88 recurring. And that is going to be in degrees Celsius. So now I need now to convert my degrees Celsius I've calculated to Kelvin, and we know how to do that. We'll just take this formula C right here. That's what we're going to use. Temperature in Kelvin will be our 148.88 recurring, and we are going to add 273.15. So I'm going to add to my answer 273.15, and the final answer, temperature in Kelvin needed in this problem, is 422 kelvins about. Again, in the homework, in the test, you'll be told how many significant figures to report these to.